All right, good morning. This is the front part that we started with, correct? And I kind of made a mistake in this part when I was talking about what extrema are. So I'm going to make it a little bit briefer. I think I included inflection points. Is that right? Yeah, cross that off. That is totally wrong. And what I'm going to simply do is I'm just going to make it really short. Extrema are maximums and minimums in an interval. Okay, I'm going to make it really brief like that. I think I got a little bit too carried away, and I apologize for that. Had I done the rest of the front page? Okay. Had I talked about this idea of extreme value theorem? Okay. Right. And the thing here, you'll get a question like, what's the maximum in this interval? What's the greatest in this interval? And I'm going to show you how to approach it. And then it'll ask you to justify. I never use the words extreme value theorem because there's already intermediate value theorem, and we're going to talk about the mean value theorem. And so I'm going to show you how to identify it, and I'm going to show you what your justification is going to look like. Okay? And you have to realize that sometimes, or a lot of times, they may give a closed interval like that. Now, hopefully you're okay with that. Did I talk about that at all? All right? And are you okay that those mean the same? And I would say you will see that like 90% of the time. Even maybe more, 97.5% of the time. Okay? All right, so next page, did I have any graphs here? Okay, so I hadn't started the next page. Is this the next page? Yeah, okay. I just got these mixed up. So let's say I'm going to put a function here. And my function is going to be f of x. I got to write this a little bit nicer here. F of x equals x squared minus 2x plus 1 in the closed interval -1 to 4. Okay, so I'm not talking about the whole parabola. Everybody understand that? So the first thing I'm going to do is I'm going to figure out, I'm going to plug in a -1 because that's my left endpoint. And what do I get when I plug a -1 into there? 4. So I'm going to scale it 1, 2, 3, 4 right here. And my other one is 4. That's my right endpoint. What do I get for that? 9. And so I'm going to just make 9 up here. I'm going to go 1, 2, 3, 4. I didn't scale this very good. All right. So this looks like the minimum. Would you agree? This looks like the maximum. Do you agree? All right. Now, this is a parabola, so it's continuous, correct? There's some type of graph between here and here. Would you agree? Because it's a parabola, and the parabola is opening up because A is positive, it has a vertex that's probably a minimum value. Would you agree with that? Okay? Or what I can call as a turning around point. At those points where it turns around, there is a horizontal tangent line. Everybody have that idea? So in other words, if I have a minimum like this, right there is a horizontal tangent line. And if I have a maximum like this, right there at that vertex, there's a horizontal tangent line. And what's special about horizontal tangent lines? we know the slope of horizontal tangent lines. Carter, that slope is what? 0. So what I'm going to do is I'm going to compute the derivative of my function, and I'm going to get 2x minus 2. And I'm going to let that equal to 0, because the slope of the tangent line, or horizontal tangent line, is 0. And if I solve for that, I'm going to get that x is equal to 1. Everybody fine with the algebra? So where x equals 1 has to be a turning around point, or has to have some type of horizontal tangent line, correct? And so what I'm going to do is I'm going to plug in 1, because if I plug 1 into f, it gives me the y value. And what will I get here? I'll have 1 minus 2 plus 1. What do I get? I get 0? Yeah, I get 0. So right here, my point is 1, 0, right here. So that means because it's a parabola and it's continuous, my graph in that interval looks like this. My max value equals my min value equals what? What is my maximum value? 9. Why is it 9 and not 4? Because it has to be a y value, right? That's the maximum f can be in that interval. Because I've restricted the domain, right? It doesn't get to go to 19. X doesn't get to go to 19. It's stopping right here at 4. Is 4 my minimum value? No, what is my minimum value? 0, because that's what my y value is when I plug 1 in there, correct? So between -1 and 4, Jeremiah, this is going to be kind of a tricky question. Between -1 and 4, how many y values are there? There's an infinite number, correct? Because you can go 0, 0.1, 0.2, 0.3, and then you go in between those, correct? But if I really want to know where the absolute minimum or the absolute maximum is going to be, they're either going to occur at these endpoints or they're going to occur at these turn around points. I don't have to look at infinity. I just need to look at where those values are. How did I figure out the values of the endpoints? I just plugged in a into the function and I plugged b into the function. How did I figure out the turning around point? I took the derivative, made it equal to 0, found what x value that would be, plugged that in, and then I just had to look at these y values. Which one's the biggest? Which one's the smallest? Is that making sense? All right, let's take a look at this next one. F of x equals 1/3 x cubed minus x squared plus x plus 1 on the interval -2 to 3. Notice this is a closed interval. So what I'm doing is really the extreme value theorem. The first thing I'm going to do is I'm going to figure out what f of a -2 is. So I'm going to mark this. Here's where a -2. What do I get if I plug a -2 into there? Well, let's do these because that's a fraction and that scares us, correct? So I plug a -2 in here, what do I get? I get -4, right? Because it's a minus sign. What do I get when I put a -2 in here? So I got -4 plus a -2 plus 1. What's that give me? A -5, right? So these, let's do those. That's a -5. Now when I put a -2 into here, what do I get? A -8/3, correct? Right? This is the same as minus 15/3. What's that give me? -23/3, right? So that's where? That's somewhere down, I think that's like a -7 2/3, right? It's somewhere down here. So this point is a -2 comma -23/3. Now, is it continuous? Yes. Why is it continuous? What is this thing called? It's a polynomial, just like the quadratic one, right? Was a polynomial. This is a polynomial. What's my next number that I'm going to put in here? 3. If I plug 3 in there, what do I get? 4? Wow, you figure that out really fast. So you got what? 27, right? 1/3 of 27 is 9. 9 minus 9 is 0. 3 plus 1 is 4. All right, so 1, 2, 3, and I'm going to go up here to 4. So this is 3 comma 4. Now, what do I have to look between these 2 points? Yes, ma'am.
So if it wasn't continuous, would there be no x or y value? I mean, min or max value?
There could be, but you're not guaranteed for sure there's one of each.
Because if there was a whole...
Right. If there was a hole, like let's say it dipped down, okay? And there's a hole there where it dipped down, there would be no minimum, but there would be a maximum. Because it's continuous and closed, you're guaranteed for sure at least one of each. There could be more, right? But you're guaranteed for sure. So the thing you'll always have to make sure is that it's continuous. Okay? So what's my next step to see if there's a turning around point? I'm going to take the derivative. So I'm going to take the derivative, and I'm going to get what? X squared minus 2x plus 1. Okay, make that equal to 0. I got x squared minus 2x plus 1. Is this factorable? What is it? X minus 1 times x minus 1. Right? That's how you solve it. So I get x equals 1. Would everybody agree? Okay. So what do I do with that 1 now? You put it into f, correct? Big mistake that students do. They take that 1 and they put it back in the derivative. Guess what they get when they put back in the derivative? 0. And so they put a point at 1 comma 0. Well, that's not right, is it? So I'm going to say f of 1. What is f of 1? Well, I'll have 1/3 minus 1 plus 1 plus 1. What? 4/3. 1 and 1/3 or 4/3. So 1, here's 1, here's 2, so I'm right here. All right, so we have kind of a different point because it's continuous, correct? Right? If it's continuous, those are only my 3 points. Would you agree with that? And what we have here is we have a slope of 0, but if we take a look at it, it looks something like this. This thing right here, you can see that it can't turn around, right? If it came up here and turned around, there'd have to be another turning around point to go back up. Would you agree? So, but notice what I did here. I changed the curvature. This is called concave up. This is called concave down. This right here is called an inflection point. Inflection point is where there's a change of concavity. You go from one type of concavity to another. It is not an extrema. They happen a lot of times with odd functions. And this is a cubic, it's an odd function. So it exists within the interval, but it's not a maximum or a minimum. So this right here is my minimum value, and this is my maximum value. Are we okay with that? Do you see why we can't turn around? Because if I turned around, I would have had to turn around and go back up, correct? Yes, sir. Like this? So I got the concavity wrong? You graphed it out? I thought you didn't like graphs, so it's going to be like that. So it's not like this. Sorry about that. All right. We're going to talk about it. I think he looked at the graph, didn't you? Or you looked at points, or what did you do? Elizabeth is right there. Carter? The rowing team. You know anything about the rowing team? Are you thinking about going to the University of Wisconsin? Do you know who Charlie O'Brien is? Okay. Do you know who Mr. and Mrs. O'Brien are? Have you ever taken a Spanish class? Do you know who they are now? Yes. Their son was on the rowing team at the University of Wisconsin. You know what you do on the rowing team? You row a boat. Literally row a boat. All right. We're going to talk about exactly, Hillary? Yeah, so those really long, skinny ones. And there's a guy that, I forgot, there's a name of a guy that tells you to keep you in rhythm. And when you do that, okay, because I did that on Lake Bemidji, and when you're all rowing together, you're just flying down that, and you're hardly even rowing. It's an amazing, and you can't step on the bottom of the boat because you'll break. It's such a thin material that you would break right through it. They do it at St. Cloud State, go up and down the river, but they do it a lot at the U. If you go by where the East Bank and the West Bank, you could see them doing the boats. There's a certain name for it, but it's pretty cool. All righty. We're going to talk about how to determine that concavity. We're going to get to that. Okay. All right, so the question is, do minimum and maximums occur only at endpoints? The answer would be what? No. Okay, so what's the difference between a relative max and min, or sometimes it's called a local max and min? So if they ask you to find the local max and mins, they're talking about the relative max and mins. and something called an absolute max and min. An absolute max and min occurs on a closed interval. And a relative max and min occur on an open interval. If there's an open interval containing C on which f of x is the maximum, then, or f of c is the maximum, then f of c is called the relative maximum of f. And I'll show you what I mean by that. Let's say I have this. Here's A, here's B. Oops, yeah, I'll put open right there. And open interval. Would you agree? Two turning around points in that open interval. This is not the maximum of that interval, is it? Okay, would you agree with that? However, within a small neighborhood, it's the maximum. An example that I give you. I live in a cul-de-sac by North Junior High. There's somebody, I think there's 10 homes in that cul-de-sac. There's somebody that makes the most money. However, I guarantee you they do not make the most money on the earth. They just make the most money in our neighborhood, correct? They have a relative maximum amount. Because if you compare them to the rest of us that are in the neighborhood, they'd be rich. However, compared to Bill Gates, they're a long ways from Bill Gates. Does that make sense? So I can create a small closed interval, right? I could say, all right, let's pick it between this value and this value. That would be a maximum within that real small interval. So I call it a relative maximum. What would this be? A relative minimum. It also applies to this. A graph that's infinite. Because really I can think of this as an open interval too, right? It goes on forever. This would be called a relative max. This would be called a relative min. It's not going to be the maximum because this thing's going up forever. So this is relative max. This is relative min. Because there's a little tiny interval, a little tiny space where this is the max and that's the min. How do I find them? I take the derivative and make it equal to 0 because I got horizontal tangent lines right there. Yes, ma'am?
Is it possible to have a graph with a relative minimum and an absolute maximum?
I suppose so. And I'm thinking about, let's say we have something like this. Let's say this side is closed. And I have something that looks like this. Relative min, relative max, absolute max. Because I've made my domain, I don't know, let's be randomly pick a number, I'll pick 3, okay? So my domain is x is less than or equal to 3 is my domain, right? Does that answer your question? Okay. All right, so right here is C. This is continuous. correct? It has a relative min. In other words, f of c, in this case, equals 0 because it touches the x-axis. However, when it is not differentiable, at c. Does anybody remember why? Yes, because there's a sharp point. Okay, so on Tuesday I was at the AP exam. Okay, I wasn't at the AP exam last year because I went to Greece last year and I didn't want to be gone from class more than what I was going to be. Okay, and you could last year say it's not differentiable at C because there's a sharp point, because that's what it looks like. You can't do that anymore. You have to say this: the limit as x approaches C from the left of f of x, excuse me, of the derivative of x, sorry, does not equal the limit as you approach C from the right of the derivative of x. The slope of this line is a -1, correct? Right, the derivative. The slope of this side is a +1. Would you agree? And so as you move on a sharp point, that is always true. All sharp points. So I can't say sharp point. I have to say that the limit of the derivative as I approach C is not equal to the limit of the derivative as I approach C from the other direction. Yes, ma'am. It's a relative min because that's the lowest y value on the graph. In this case, it is an absolute min, yes, because it was an open interval. Are they going to dock you whether you say it's absolute or relative? No, okay. But if you're on a closed interval, you know for sure it's absolute, okay. So now I'm going to compare it to this. This also has an absolute min, correct? It's continuous. I'll say it has absolute min this time. It is differentiable. Why is it differentiable? Because the limit as x approaches C from the left of the derivative is equal to the limit as x approaches C from the right of the derivative, and that number is 0. You could see that. If I look at the tangent lines, they start to decrease, right? Here's a tangent line. Here's a tangent line. It starts to flatten out to 0 on both sides, correct? So the point of both of these are minimums or maximums can occur when the derivative is equal to 0 or when the derivative does not exist. We're going to look at these more in a second here. Next page. Is this the next page? Yeah, I'll make sure I get to write down here. Skip this picture. All right, so slopes at relative min or maxes, or absolute maxes or mins, the slopes are 0. The slopes at relative maxes or mins, or absolute maxes or mins, do not exist. Both of them can happen. This looks like a graph that either looks like this or looks like this. This indicates that this is a max, but it's a sharp point. This indicates this is a min, but it's some type of sharp point. Here, the derivatives are negative. Here, the derivatives are positive. Excuse me. Here, the derivatives are negative. Here, the derivatives are positive. So I got this definition. If the derivative with c plugged into it gives you 0 or does not exist. So if the derivative is equal to 0 or if the derivative does not exist when you plug c into it, we call c a critical number. We're saying it is important. If there's a relative max or min, or an absolute max or min, they have to happen. Well, these could happen at endpoints. But relative won't happen at endpoints. The relative max or mins will only happen at critical numbers. But critical numbers don't always yield relative extrema. Here's my example. Y equals x cubed. The graph of y equals x cubed looks like this. We take the derivative of that. We get 3x squared. We make it equal to 0. And we find out that x equals 0. So x equals 0 is a critical number, but there is no max or min on this open interval because it's going on forever, correct? Now, let's look at this. F prime equals 3x squared. Except for 0, I plug in a -1. I get a slope of what when I plug in a -1? What do I get? 3. So right here is a tangent line. It has a slope of 3. I plug in a +1. I'll also get 3. Correct? In fact, except for 0, for every number I put in for x, won't it be positive? Won't my tangent lines be going from the bottom left to the upper right? Doesn't that indicate that my function is increasing on that interval in infinity? Isn't it increasing the entire way that it doesn't turn around? Because the derivative is always positive for all values that aren't 0. It's always a positive, so it's always increasing. Well, if it's always increasing, does it ever turn around? No. Is there a relative min or max? No, because it's always increasing. Now notice what happens to the tangent lines. All the tangent lines here are on this side. Then all of a sudden on this tangent line, it switches, correct? Why does that happen? Because the tangent line, for a very brief moment, when it gets to 0, is like this. It has a slope of 0 and then switches back. Because it's got to get to 0 because positive, 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 0, and then it's got to become positive again. In fact, if I graph this derivative, and I'll graph it in a different manner, it'll look with a different color, I mean. This is the derivative. If this is the derivative. Now, it's not accurately drawn, but it's a parabola, and this is f of x. Notice my derivative is always positive except for 0. This derivative has to be above the y-axis because this function is increasing. This derivative has to be above the x-axis because this function is increasing. So wherever the derivative is above the x-axis, the function is increasing because the derivative is positive. Where the derivative is below the x-axis, it's negative, isn't it? My function has to be decreasing. We're going to come back to that Monday. So guidelines for finding extrema on a closed interval. Remember, when you have a closed interval, you are guaranteed to have an absolute max and an absolute min. So you find the critical numbers. How do you find the critical numbers? You take the derivative. And you solve. Once you find those critical numbers, you plug them into f. And this should be like this. Evaluate f at each endpoint. So figure out f of a. Figure out f of b. Over here, you're going to get x is equal to some critical number I'll call c. You're going to plug that c into f. You're going to get a value. And whichever is the smallest of those numbers is going to be the minimum. Whichever of those y values is the biggest is going to be a maximum. Let's look at this example. I believe this is 3x to the 4th minus 4x cubed. I'm sorry about the small print. So what I'm going to do is I'm going to take the derivative and I'm going to get 12x cubed minus 12x squared. That's my derivative. That's what makes my slopes, correct? Or computes my slopes. I know the slopes I'm looking for. I'm looking for slopes of 0. Does that make sense why we're looking for slopes of 0? Because that's where the horizontal tangent lines are. So what am I going to do here? How do I solve for what x's give me zeros? How would you do that here? Factor out a what? 12x squared. And I get x minus 1. So what are my critical numbers? X equals what? 0 and x equals 1. These are my critical numbers. Critical numbers are always x values. Then, so these are my C's. I have two C's. C1, C2. I'm going to plug one of them into my function. What do I get when I plug 0 into here? 0. What do I get when I plug 1 into there? -1. Over here are my endpoints. I'm going to plug in -1 into here. So I'm going to have a -1 to the 4th, and I'm going to have a -1 cubed. What's that going to give me? 7. I'm going to plug in the other endpoint, 2. So I'm going to raise 2 to the 4th power, multiply by 3. I'm going to take 2 to the 3rd power, multiply by 4. 2 to the 4th, what is that, 16? 16 times 3, is that 48? Okay. Minus 2 cubed, I believe, is 8. 4 times 8, is that 32? I get 16, don't I? So, my left endpoint has a value of 7. I had a critical number of x equals 0. I got 0. I had a critical number of 1. I got a -1. I had a right endpoint of 2. I probably should have put a -1 here. I had a right endpoint of 2, and I got 16. Those are the only 4 numbers I have to consider. Which one's my max? 16. Which is my min? -1. So I'm going to graph this. I'm going to have, what is this number? -1. Right here is going to be 7. I have that point. I have 0. I have 1 is a -1. And I have 216, which is up here somewhere. So my graph, now I got to get down to here, don't I? Right? Would you agree? Right? Would everybody agree? Now, I got to go from here to here. It's continuous, correct? Is this a turning around point? Okay. If it comes down here. If it's a turning around point, where does it have to go? Up. And I got to get to here. So if this is a turning around point and I go up, there has to be another turning around point to go back down. Would you agree? There isn't one, is there? So is that a turning around point? No. So I'm going to guess that it goes like this. And goes something like that. Now, can I use your calculator, Jonathan? You already have it already? Okay, I'm going to blow this baby up a little bit. Is that okay? Not perfect, but close, correct? I know that's not a turning around point. This one is a turning around point. That's a minimum, isn't it? That one up there is a maximum. One thing I would do, oh yeah, you probably had it right till I always make my window the 2 endpoints. Does that make sense? But I blew it up, so I screwed it up by that. Does everybody understand what I mean by that? Okay. All right so far? Here you go, John. Now, let's take a look at this one. Number 2. I'm going to find the extrema. Well, one of the things I'm going to do is I know I have to take the derivative. Tyler, can you take the derivative of that for me? To what power? Perfect. Okay. And I'm going to make that equal to what? 0. Well, okay. I'm not going to yet. Okay. I'm going to talk about that in a second. All right. So if I write this out, the derivative looks like this. So I got a negative exponent, correct? Everybody agree with that? So I'm going to have 2 minus 2 over x to the 1/3. When you do that, make sure you get a common denominator. What's my common denominator? X to the 1/3. So this is over 1. So I'm going to have to multiply this by x to the 1/3. And I'm going to have to multiply this by x to the 1/3. Would you agree? So my derivative is 2x to the 1/3 minus 2 over x to the 1/3. Now, what I'm going to do is I'm going to let the numerator be equal to 0. And I'm going to solve for it. Does everybody see where I get 1? That means this is a 1/3 power. So that means x equals 1 is a critical number. Everybody with me so far? Now, I can get critical numbers from the denominator also. And I'm going to let that equal 0 also. And I get 0. Why do I let the denominator equal to 0? Because if my absolute max or min is a sharp point, it's going to come from the denominator. Sharp points come from the denominator. Sharp points come from the denominator. Smooth points. You know what I mean by smooth? This is smooth. This is smooth. This is sharp. This is sharp. Smooth points come from the numerator. So I have two critical numbers, x equals 0, x equals 1. I'm going to put x equals 0 into my function. Now, can I put 0 into here? Am I allowed to say 2 times 0 minus 3 times 0 to the 2/3 power? Am I allowed to do that? Yeah, there's nothing wrong with that. What do I get? 0. I put 1 into there. What do I get when I put 1 into there? Well, I'm going to have 2 times 1 minus 3 times 1 to the 2/3 power. 1 to any power is 1, so what do I get? -1. Now what I'm going to do is I'm going to plug in f of a -1 in there because that's my left endpoint. So that's going to give me a -2 minus 3 times a -1 to the 2/3 power. Are you okay that the third means to take the cube root of a -1 and that the 2 means to square that? Are you okay with that? So what's the cube root of a -1? What number times itself 3 times gives you a negative 1? Negative 1. What do I get when I square a negative 1? 1. So what's a negative 2 minus 3 times 1? A negative 5. Now I'm going to plug in 3. And I'm going to have 6 minus 3 times 3 to the 2/3 power. Well, I'll probably need a calculator for that. John, what did you get for that? I should have brought my calculator in. What it? A negative 2.4. Is there any more decimals? So 0.3. Right? Negative 0.24? I heard wrong. Like that then. Correct? I could just drop the 0, right? Everybody with me on that? Now, what's my min? Negative 1. Awesome. Oop, negative 5. Sorry. I forgot about negative 5. What's my max? 0. All right, do you have a graph? Okay, can I borrow it? You got this nice one where I could do that. Okay, would everybody agree? Now I'll show you what I mean by this. I'm going to go to my window, and I'm going to choose my closed interval negative 1 to 3. Does everybody understand why I choose that? And then I've already got some y values, so I'm going to go 0. I'll probably choose 1, go a little bit above it. And then I go down to a negative 5, so I'm going to go to a negative 6. Does that make sense? What? Calculators. Okay. Now, the reason I like this one is you can see there's a sharp point there. Do you see that? So my sharp point is at 0. Should be 0, 0. So I suppose it goes to 0 right here, right? I suppose that's coming up to 0, but that doesn't look like it, does it? Oh, you don't. You just have a trace button, don't you? Yeah, there it is, 0. It's just so sharp. It's a very sharp point, its head up there. So back here, that's why you have to look in this denominator. So that's why you've got to take and make one complete fraction out of those expressions to find that. All right, so let's take a look at this. How much time do I have? We'll be able to finish this period? I think this is the last one, isn't it? There's nothing on the back side? Okay. Do you understand why I chose that one? So when you take the derivative, you have to take a look at the denominator and the numerator. The denominator is where there are possible sharp points. The numerator, where there are smooth points. Right here, I didn't need to take a look at the denominator here because the denominator is 1, isn't it? It is a polynomial expression. There are no fractions on this one. So let's take a look at this. So I'm going to take the derivative. Hillary, let's take the derivative. First term, what am I going to have? Minus a 2x, correct? So it's this. Well, the derivative of cosine is negative sine. And then you have to do the chain rule. You have to take the derivative of the inside and get 2. Okay, and so she said, she put the 2 and the negative sign together and said it's a negative 2. Does that answer that? Okay, I'm going to make this equal to 0. And the reason I brought this one up is because everybody's scared of trig. Are you, can I make it less scary if I do this? I want to get rid of you. Go away. Everybody okay with that? Now, there are two identities you need to know in this class. Cosine squared x plus sine squared x equals 1. Does anybody remember what the other one I said you had to know? Sine of 2x is equal to 2 cosine x sine x. Only 2. This one you should have down pat, don't you think? So that's the one you just got to know. So I have plus 2 cosine x sine x. Does anybody know how to solve that? Yeah. I could factor it, right? I get 2 sine x. Would you agree with that? Yeah. Okay. So that means the cosine of x equals 0. And it means 1 plus 2 sine x equals 0. And it's a closed interval, right? From 0 to 2 pi. So where's cosine 0? Two places. It's got to have pi in it, because they're radians. Pi over 2 is 1, and 3 pi over 2 is the other. These are my critical numbers, because they came from the derivative. My denominators I don't have to worry about here, right? Everybody understand that? I'm not going to have any sharp points. So here I'm going to have the sine of x equal a negative 1/2. Sine is negative in what 2 quadrants? You can't use a calculator. You're not allowed to use a calculator in this one. Why? Third and fourth, because y is negative, the third and fourth. Okay? So now that I know it's in the third and fourth, I'm going to forget about it for a bit. Where is sine 1/2? Pi over 6, correct? So over here, because I can't remember diddly, right here is pi over 6. But I got to be in the fourth, and the third quadrant, correct? And I'm going from 0 to 2 pi. So how much is that? This is pi, correct? Plus pi over 6, correct? What is that? Okay, 7 pi over 6. This to here would be 2 pi, but I got to back off pi over 6, right? So what would be 2 pi minus pi over 6? 11 pi over 6. That's how my brain works. I first decide what quadrants they're in. Then I come over here and I draw a picture. Where's pi over 6? Well, I can't be in that one, so it's got to be in these two. I remember that this is 2 pi. If I go all the way around, I remember this is pi. So in one I add, and the other one I subtract. So those 4 are my critical numbers. Everybody have that? Those 4 are my critical numbers. So I have 6 values in here. I have to put 0 into there. I have to put 2 pi into there. I have to put pi over 2 into there. I have to put 3 pi over 2 into there. I have to put 7 pi over 6 into there. And I have to put 11 pi over 6 into there. Well, aren't 0 and 2 pi the same location? So once I figure out 0, isn't 2 pi going to be the same answer? So I'll plug in 0 in there. The sign of 0, what is it? 0. So 2 times 0, boom, gone. If I plug in 0 and multiply it by 2, I get 0. What's the cosine of 0? But it's got to be negative, correct? Negative 1, negative 1. I'm going to put in pi over 2. What is the sign of pi over 2? Let's try it again. 1. What's 2 times 1? 2. Minus. What is the cosine? Well, 2 times pi over 2 is pi. What's the cosine of pi? Negative 1. So I got minus a negative 1. What is 2 minus a negative 1? 3. Now I'm going to put 3 pi over 2. What is the sign of 3 pi over 2? Times 2. Negative 2. Minus. Well, 3 pi over 2 times 2 is 3 pi. What's the cosine of 3 pi? The same as pi, right? So that's a negative 1. Am I right? So minus a negative 1. What's a negative 2 minus a negative 1? Negative 1. Seven pi over 6. Sine of 7 pi over 6. The negative 1/2 times 2 is a negative 1. Minus. All right, here's the tough part. 2 times 7 pi over 6 is 7 pi over 3. 6 pi over 3 is 2 pi. So 7 pi over 3 is exactly like pi over 3. What's the cosine of pi over 3? Anybody know? One half. So what's a negative 1 minus 1/2? I get a negative 1 and 1/2, or negative 3/2. 11 pi over 6. Well, what's the sign of 11 pi over 6? We should know this. Negative 1/2, so that's a negative 1, minus, okay, where is 11 pi over 3? Well, 6 pi over 3, correct? 6 pi over 3 is 2 pi. 12 pi over 3 is 4 pi. Isn't that the same location? So 11 pi over 3 is in the fourth quadrant, correct? But cosine and sine, or cosine, is the same in the first and fourth quadrant because it's x. So it's the same as pi over 3. Do I know the cosine of pi over 3? Well, I just did it. 1/2. What am I going to get? Negative 3/2. So now you just got to decide what number is the max and what number is the min. What's my smallest value? Negative 3/2. Maximum value is equal to 3. Now, have I showed you how to figure out what the minimum and maximum value on your calculator is? Give me your TI. We'll finish it tomorrow. And then that'll take about 5 minutes max. And then the rest of the time is work time. Does everybody understand that? All right. You guys have been beautiful people. I should tell you more often how wonderful you are. Okay? Thank you, thank you, thank you. It was pretty intense.